Hello friends, this video on Organic Chemistry Basics Part 42 is brought to you by examfear.com. No more fear from exam. Go to the next method called crystallization. Before we go to the next method called crystallization, let's understand the concept behind crystallization. And there are certain solids which form crystals. Please don't, you must have seen, for example, sugar. Sugar is a crystal, right? So sugar is one example of a solid which form crystals. So this will be used only when you have this method will be used to purify only solid crystals. We will talk about that. Example, sugar is one example of solid crystals. So what happens in the crystal is, you take a crystal, and if the crystal has some impurities, the green ones are my crystals and this black one is my impurity. So what happens is, you heat this crystal, what will happen is the molecules of the crystals will go apart, right? It will be something like this. And then when you cool it back, it will come again in this fashion. Because there is a force of attraction. We talked about crystals energy, right? Because this makes things more stable. The whole crystals make more things more stable. And that's why we talked about NaCl also, yeah, it has a crystal shape, right? Sugar also has crystal shape. So crystallization, in fact, increases the stability, decreases the energy. So if you see, this is my energy actually, this guy. And this I can take as time also, because as I am heating it now if I heat this will become in this stage, and then when you cool down, it will be in this. And if you see, the new crystal form has lesser energy. This is a little unstable, this is more stable, right? Why? Because it is not having any impurities, so it's a perfect crystal, correct? And that's why it has less energy. So this part is my energy side, and this time. So if you see, let's see the experiment. Let's heat this. Let's start heating this crystal in a solvent. And what will happen, if you see, as the time passes by, if you see this crystal, the time is passing by, this crystal is in this state now, right? Now if you see, now I have removed this heat now, and it's cooling down. Now if you see the way it's cooling down, this impurity went down and these crystals crystallizes on its own and it becomes this crystal, correct? And please note, the cooling has to be slow. Cooling has to be slow, because if you do a fast cooling, then this impurity may not come down. The impurity may again get trapped. So let's see this once again demo. So what happened is, this was my condition here, right? I heated this, I am supplying heat, Now this crystals is broken because of the heat we are giving, the crystals are broken. And now we have stopped applying heat. Now it's getting cooled. Now with that, the crystals are again forming, the molecules are again forming the crystals. And while forming the crystals, this impurity is not considered, and the new crystals form is pure, correct? Let's see it once again. So I'm supplying heat. With the heat, what happens is, crystals breaks into molecules, and these molecules are far apart, right? And this impurity is again different. Now I have stopped supplying heat. It cools down on its own very slowly. It recrystallizes, and in the process of recrystallization, the impurity will not be part of crystal, and if you see, the new crystal formed is totally pure. This is the technique of crystallization. We'll talk about the purification techniques now. Just understand, this is the technique we use for crystallization. So as I told, this is used to purify solids, only solids which form crystal. For example, sugar, benzoic acid, these are two examples of organic solids which are crystals. If you want a non-organic example, you can take NaCl, that is also crystal. So this is used only for solids and which are crystals, correct? So you can, and if you see, this is how benzoic acid look. Don't get confused with the term benzoic acid, so it will be liquid. Benzoic acid is solid in nature, actually, it's solid. And sugar, you all know, you must have used in your home. Sugar is also crystal shape. So now let's understand this method called crystallization. If you see, it is the most commonly used techniques, and it is used for solid organic compounds which are crystal in nature. It's very commonly used technique, and it is based on difference in solubility, as I just explained, of the compound and the impurities in the solvent. So you take some solvent, the whole thing happened in a solvent. You must have seen the just experiment I just showed. So the whole thing happened in a solvent, and the solvent has to be very suitable. We'll talk about the criteria for a suitable solvent. So the whole thing happens in a solvent. The solvent has to be suitable, and the condition is there is a difference in the solubility of the compound and the impurities. For example, if I am talking about the compound, for example, the compound here is my benzoic acid or sugar, and the impurity is, let's suppose, dust, right? So we have to choose a solvent. There is a good difference in solubility between sugar and dust. We'll talk about this in the next few slides when we'll say that how to choose a good solvent in a crystallization process, and that's a very critical step because a good solvent is must for this process. So what happens in this is the impure compound actually will dissolve in the solvent. In the solvent, generally it is not that soluble in the room temperature, but when you heat it, it is soluble. Correct? So we generally choose a solvent where, for example, if you want to purify sugar, we'll choose a solvent where sugar is not easily dissolvable in the room temperature, but when you heat the solvent, the sugar gets dissolved. So we'll pick that kind of solvent. So now what happened is, for example, you have the solvent and you have this sugar, impure sugar, right? Impure sugar. You mix it, it won't get dissolved. You heat it, it will get dissolved, right? Now what happens is, even the dust may not get dissolved. There may be some stone, something which it doesn't get dissolved. Now what you do is you filter it with a filter paper. So with that, at least the dust and all will be here. So you do one layer of filtering here. So now this has sugar and some solvent and some other impurity, right? So with this I have removed some impurity, some other impurity are still there. Now I will allow it to cool. When it cools, the other impurities is kicked out and you get sugar crystals. We'll show you the experiment of this, how it is done. So let me repeat what I have said till now. So I have my impure compound, impure sugar. It is in a proper solvent. I'll tell you how to choose proper solvent. You mix it. It is not soluble at the room temperature, but when you heat it at a high temperature, it is now soluble, right? And the solution will be now saturated. You just keep pouring more and more impure sugar so that you make a saturated solution, correct? And make sure all this sugar is dissolved. And then you can remove this extra dust by this or extra other impurities which are not dissolved in the solvent, because see, the impurities which we have in sugar can be of two types. One is the impurities which is dissolved in the solvent, and the impurity which is not dissolved. For example, stones you have, marbles in the sugar. So those impurities which will not be dissolved in solvent at all. So those impurity which is not insoluble impurity, no. So insoluble impurity you can filter it directly from this filter paper, correct? And this will have soluble impurity. So soluble impurity, now when you filter from filter paper, you have sugar, you have solvent, you have soluble impurity. Now what you do, you allow it to cool, and then you will see the crystals coming out. And whatever crystals you get, you can again remove from filtration, correct? Because the crystals are big and solids, and the solid will be liquid. You can easily do filtration and get the crystals out. And you can do repeated crystallization if you want to make more and more pure compound. For example, you have, let's suppose, 80% pure, or let's suppose you have 10% or 50% pure, 50% pure organic compound. You crystallize this, it becomes 70% pure. You again recrystallize, it becomes 80%, 90%, and then you can make 99%. So you keep doing this same process of crystallization to give pure and pure form of organic compound. Let's see the experiment. As I told, what does we do in the experiment? So what we do is we take a suitable solvent, right, and then we take an organic compound. So in this case, let this be sugar, right? So we will take solvent plus sugar, and that is impure, correct? So we took, this is blue is the solvent and I have sugar, impure. It is not properly dissolved in this water because we are talking about the room temperature. So we'll heat this. So what will happen is, on gradual heating, the sugar will dissolve and it will be in this solution, correct? Now this sugar may have soluble impurity and insoluble impurity, correct? For example, big, or you can say glass. So let's suppose some glass pieces are there, right? And some soluble impurity, for example, you can say dust, right? A coal, anything, a mud, right? So what we do is now we take this funnel, we put this filter paper, and now we'll take this whole thing and we'll put it here. So with this, what will happen? All this insoluble impurity will be here, right? So all this insoluble impurity will get here. Insoluble impurity. Correct? So now we have got all the insoluble impurity. We'll remove this funnel, everything from here. So I have got all this insoluble impurity removed. So now this guy has soluble impurity. Now, right, you see this guy has soluble impurity and sugar, right? Now it is in this stage now. So this is my stage now. This is exactly this. So now what we'll do? We'll actually, sorry, this is in this stage. This is in this stage, right? This is because the sugar is dissolved and we have some impurities also. These are soluble impurities, right? They are dissolved in the solvent. Now what we'll do? We'll allow it to slowly cool down. If you see, you'll get more time, slowly. If you see, the color of this solution is fading away because the sugar is coming out of this solution and becoming sugar crystals. So you see, after some time, the sugar crystals came, and these are my pure ones. And this is nothing but this stage. Hope you understand what we have done. So we got a pure sugar crystals. This is my crystallization. As I told, we'll discuss about the suitable solvent for crystallization. So let's discuss what are the criteria for selecting a suitable solvent for crystallization. See, the first one is pretty simple. The substance which I have, for example, sugar or benzoic acid, any organic compound which you want to purify, that should dissolve in solvent. That is the first thing, because if it doesn't dissolve in solvent, there is no question of crystallization, right? So, and that too, that should dissolve on heating, and on cooling it should come out. Correct? So the solvent should be such that if you have a organic compound to purify, that should not dissolve at room temperature, but when you heat the whole solution, it should dissolve, and when you cool it back, the organic compound should crystallize and come out. That is the first. The second is, there should not be reaction, so the solvent should not react with the substance to be purified. For example, I have sugar, I should not have solvent such as sulfuric acid because it will react with sugar, right? So you should have a solvent which will not react with the organic compound to be purified. And the third one is, the best is you get a solvent where the impurity is not dissolved. That is the best scenario. So in that case, using filtration only you can find, but that doesn't happen, right? So because in a particular organic compound, impure organic compound, you can have impurities which is dissolvable and which is not dissolvable, right? Which is soluble and insoluble. So what if you are not able to find the solvent? So in that case, the solvent, if they dissolve impurity, if they dissolve impurity, in that case, the solubility of impurity should be very, very high. Why? See, in this case, I am saying is, I have my beaker and I have this, I want this, what you call crystals to come out, right? I want crystals to come out, but I want impurity to remain dissolved in solvent, correct? See, the impurity also come out and it forms crystals. It will be tension for me to separate. So the impurity is highly soluble. Impurity is highly soluble in the solvent. It will be in the solvent only, and then my crystals of sugar or benzoic acid or whatever organic compound I am trying to purify will come out. Correct? So see, first is, if the solvent does not dissolve impurity, that is the best thing. But if that is not possible, in that case, you should find a solvent where the impurity is highly soluble. Is highly soluble, so that my crystals of organic compound come out, but the impurity is in the dissolved state. For example, to purify sugar, ethanol is used, and in sugar we have common salt as impurity, right? and common salt is highly soluble if not, sorry, common salt is not soluble in ethanol itself, so it is not soluble. So in that case, this is the first scenario. This is the first scenario where you can easily take out common salt, or kick out common salt from the sugar. So two scenarios. One is, if it's best if you find a solvent where impurity doesn't get dissolved only, but if you're not able to find, then you find a solvent where it gets dissolved the max. So it's always min or max. It's always min or max. Either don't dissolve at all, or it dissolve it very, very high. Correct? Should not be in between. So here is my organic compound, which will be in between actually, generally, because here you try to heat and cool and form the crystals. Correct? So this will be my organic compound in center, and this will be my impurity, and this will also be my. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.